You know, we often hear that quantum field theory is the single most successful scientific theory in all of history. I mean, it predicts what tiny little subatomic particles are going to do with just mind-boggling accuracy. But what if that whole incredible structure is built on a shaky foundation? Today, we're going to dig into a really fascinating critique that claims there's a huge hole in the way we describe reality itself. So yeah, let's dive in.
It all really kicks off with a question that sounds simple on the surface, but it's actually incredibly deep. Where do all the numbers that we use in physics actually come from? Think about it. All of our equations, from gravity to electromagnetism, they're all built on these numbers. But what's their origin story?
And here's where it gets really interesting. This particular critique says that quantum field theory, well, it doesn't have an answer to that question. It just kind of assumes the numbers are there, all ready to go. And this isn't just a minor little detail. Oh no. This is presented as a fundamental flaw that could, potentially, pull the whole rug out from under the entire theory.
All right, so first up, let's tackle what this viewpoint calls the ontological gap. And ontological is just a fancy word for being about existence itself. This really is the heart of the objection to the theory as we know it. The key term we need to get our heads around is number constructs. This is basically all the math, the fields, the values, all the tools that QFT uses to make its predictions. Now, the point being made here isn't that the math is wrong. It's that it's rootless. It's like these numbers and fields just poof, appear out of thin air, with absolutely no explanation for why they even exist.
So, this leads us right to the central claim. Quantum field theory is like having this brilliant, perfect instruction manual for a machine that apparently has no designer and was never built in a factory. It can tell you exactly what all the parts do with incredible precision, but it never ever explains where those parts came from. They just are.
Okay, so you've got this big hole, this gap. Well, the argument is that this gap leads directly to a major conflict, a problem that's based on what the author calls a false definition.
So here's where we get into the technical weeds of the dispute. On one hand, the author asserts that numbers are fundamentally discrete. They're like individual Lego bricks, right? You can have one brick, you can have two bricks, but you can't have half a brick. So anything you build with them has to be discrete, too. But on the other hand, QFT often treats its fields as being continuous, like a smooth, unbroken sheet of glass. And this, right here, is presented as a huge fundamental contradiction.
And wow, this perspective does not pull any punches. This quote gets straight to the point. It's basically saying that when you ask QFT proponents to really define this idea of continuity, to build it from the ground up, they can't. The argument is that it's impossible, and that this points to a really deep, unresolved problem right at the core of the theory. So if you're going to claim that the foundation of modern physics is flawed, you'd better have a solution in mind, right? Well, there is one. It's a whole alternative framework, an idea called the fabric of reality.
The fabric of reality, or FOR for short, is put forward as the big missing piece of the puzzle. The idea here is that it's not just some passive background like a stage where physics just happens. Oh no, it's a fundamental, active medium. The idea is that this fabric is the thing that is actually generating the numbers, the fields, and even the physical laws that QFT just takes for granted. It's the source, not just the description.
So what would this fabric of reality actually do? Well, you can think of it as having a three-part job description. First off, it would give us a reason for numbers to exist in the first place, finally closing that ontological gap. Second, it would be the engine that actively creates the fields QFT uses. And third, it would provide the underlying structure from which the great equations of physics, like the Dirac equation, could naturally arise. And this really brings us to the core of the whole disagreement. It all boils down to the difference between, using a really powerful tool and being able to explain where that tool actually came from. So, when you strip it all away, you're left with two fundamentally different perspectives. On one side, you have quantum field theory, which is presented here as this amazing, powerful tool that works brilliantly, but you just have to accept its component parts as a given. And on the other side, you have the proposed fabric of reality, which is framed as the actual source, the factory, if you will, that creates those very tools in the first place. That is the heart of it. And that leaves us with a pretty profound final question to chew on, doesn't it? I mean, quantum field theory is unbelievably successful at describing how the universe works. But is that enough? In our relentless quest for knowledge, is it okay to just have the right answers? Or do we, and should we, demand a theory that also explains why those are the right answers?